Today we are going to learn about solubility of salts. As you know, salts are ionic compounds. And before that, let us get familiarized with salts which are soluble and salts which are insoluble. So you may refer to the table given here for some of the salts which are soluble together with its exceptions, and also the insoluble salts together with the exceptions. With reference to the table of the solubility of some common ionic compounds, we may classify the salts here. The soluble salts, for example, lithium chloride, potassium hydroxide, sodium carbonate, sodium nitrate, and lead nitrate. Salts which are insoluble, for example, lead chloride, copper hydroxide, calcium carbonate. In this image, you will see the appearance of precipitates for several salts which are insoluble in water. As we have been familiarized with salts which are soluble and insoluble, let us take a closer look at what happens in a sparingly soluble or insoluble salt like silver chloride. There is an equilibrium that exists between the solid solute and aqueous ions. In a saturated solution of a sparingly soluble salt silver chloride, equilibrium is established between the solid phase and the ions of the salt in the solution above the solid. This is a state of dynamic equilibrium in which two reverse processes, dissolution and precipitation, proceed at the same rate. The process can be written in the following way, where there is an equilibrium between silver chloride solid and the dissolved ions of silver ions and chloride ions. As we have seen what happens in a saturated solution of a sparingly soluble salt, let us now see how to calculate solubility. There are two measurements that we can use to calculate solubility. Firstly is solubility gram per liter, which is defined as the mass of solute that dissolves in a given quantity of solvent to form a saturated solution. And secondly is molar solubility, measured in mole per liter, which is defined as the number of moles of solute that dissolves in 1 liter of saturated solution. These two ways of measuring solubility are interconvertible, as seen in the diagram.